Good morning, developers. If you are new to the channel, my name is Rob, and I want to give you everything you need to make your own chat app in Socket.io. And this is going to take about 60 minutes, give or take. We'll see where we end up by the time it may be a little longer or a little shorter. And if you've done one of these before, a tutorial or looked around, you might be thinking, hey, Rob, it shouldn't take an hour to do that. You are right. We are going to do more than just make a chat app, which is to say my goal isn't really to teach you how to make a chat app with Socket.io. It's to teach you how to use Socket.io. I've been using it for about 15 years, going back to 2008 or 9, about that, when WebSockets were a new thing, when even Node.js was a new thing. And so this is awesome, right? We got a new cool thing to play with built into JavaScript, except it's not supported all the time, so I'm going to use Socket.io. We'll come back to that. Okay, so I start looking around online for some tutorials because there's not a lot out there, and I find, oh, here's a tutorial how to make a chat app. Kind of go through it, and I build something. Don't really know how it works because it was focused on code, but I made something cool. I look for another one, pretty much the same thing. I keep looking, chat app after chat app, and two sort of conclusions emerge. One, Socket.io is the chat app thing. When you need a chat app, you grab Socket.io, and until then, it just sits on your shelf. And two, nobody knows how this thing works because nobody was ever talking about it. It was pretty much just here's the code to put your chat app together. Now, again, that was in the very beginning. Things are different now, but they're not that much different. It still is hard to find out how this thing works, and two, it's still kind of known as maybe the chat app thing, or at least a lot of developers lean that way. And I want to debunk both of those. It is a pitiful representation of what WebSockets or Socket.io, those will be interchangeable for a little while until we explain it. But that's a pitiful representation for what they are capable of. There is so much more probably in your applications right now that you could be doing with it that you maybe don't know until you have a sense for how they work and see maybe another example. And two, the under the hood stuff, yes, it is different, but it is not that complicated and it is not that different. So the way that the video is structured is, first of all, we're going to talk about this. This is the logical place to start. What is Socket.io? You may have used it before. You may have some notion. You may be confused. You may have never used it. You're just here because you want to make a chat app and you want to use Socket.io. Whatever the case, we need to make sure that we're on the same page. And as part of that, I'm going to go into contrasting, so we'll draw out the whole process. I'm going to contrast it with HTTP, because if you are a web person, you are familiar with HTTP, whether you know it or not. You use Axios or Fetch or Ajax or something like that to make HTTP requests back and forth to a server or something like that. WebSockets are not like that, right? Socket.io uses TCP and it is different, and I want to kind of make sure up front you understand what the process is like. From that, we'll kind of come back to the question, what is Socket.io? And we need to answer these questions. What are WebSockets? And we're going to need to look at the underlying networking protocol, which is TCP. This is sort of the no coding section of it. And I'll go ahead and put that around here. No code. And we're also going to have the drawing in there too, so that'll be part of this. But you may be the type of person who says, Rob, I don't do no code stuff. I don't want to hear your concepts. Just show me the lines of JavaScript in Node.js. Let's get into it. Please, if you're that person, please consider watching this. At least give it a try, because if you go straight to code, you end up in that same place that I was at for years, where I didn't really understand how it worked and I didn't understand any of the other applications. Okay, so this is the non-coding, and it is very important in my opinion. You can get a chat app tutorial in a zillion places and it will do a good job. So a lot of the value is going to come here. Then we will make our chat app. And this part we're going to do in JavaScript and Node. There are other implementations of Socket.io, but we're going to do it in Node. This will get us to the point where we can set up the server, a couple of the different options, and we can work on, it's going to be simple. The UX is not going to be flashy. You can make it flashy if you want to, but it will make you familiar with emit and on. Those are going to be the two really big methods that you'll need to know. And then, as I said, a lot of the setup that goes into it, things like just getting the socket server up and running, okay? And then after that, I am going to show you another project. We are not going to build it because there's a whole bunch of other cool stuff that Socket.io has that we can't do in less than like 15 hours if we actually code it out. So I am going to take you through another project that I have, and it will give you a chance to see some of the work. You can pull down the repo and you can go through it line at a time, and you can make modifications if you would like to. Okay, so that is the plan for the video. Let's start off with what is Socket.io, and I'm going to pull up the documentation here. This is the Socket.io homepage, so these are the docs. It claims about itself. It is bidirectional and low latency communication for every platform. Okay, so let's break that down. Bidirectional, low latency, I'm just going to do LAT, and then every platform. Okay, so those are our three points here. Bidirectional. Okay, this is going to come in where we're going to draw a little bit. So let me switch colors. Typically, when you set up a website, you're running JavaScript on the front end. That's not typically, that's what you are running. There aren't any other options unless you have WebAssembly or something like that, okay? So we've got JavaScript over here, and I'll put that in there. Here's our JavaScript on our client. And then over here, we have ourselves a server. And it doesn't make any difference what kind of server it is. It could be Node, it could be PHP, it could be Python, it could be Java, C#, etc. Okay? They do not know, what the other is. This just knows it's getting HTTP requests. This just knows somebody on the other end is going to respond to my HTTP request. Okay? When we need data, we make a request. And again, that is using HTTP. Now, you may not know what goes on under the hood. An HTTP request has a header and it has a body. And in the header are things that you're familiar with, maybe MIME types, size, the date it was issued, all of that stuff. And then the body is going to be, on the request, is going to be usually pretty much empty. But the request goes out and the client waits. The server does, it's going to be listening at, let's say, port 3000. Okay, it doesn't matter what port. And it does its thing, right? Node.js or Java or whatever. It does something with that request, and then it responds, and then the connection is terminated. Okay? HTTP is stateless, meaning it does not maintain a memory or a log or a history or state of that connection. It's just request, response, we're done. If you want to make another request, you can, but we're starting from scratch. I won't remember anything about you. You're going to have to tell me who you are and what you want every single time. That's how HTTP works. The connection is made, and then once it's fulfilled, the connection is severed, and you have to start completely over. Okay? What we are using, what Socket.io uses under the hood WebSockets. And you may or may not be familiar with WebSockets, but this is a native JavaScript API. This is built into JavaScript. And as I said, back when I started, like in 2009, WebSockets were brand new and support was not consistent across the browsers. You had no idea whether it was going to work or not. So there were a couple different ways of managing it back then. Now pretty much everything uses WebSockets. So Socket.io is sort of a layer on top of WebSockets. And the way that it works instead here is I'm going to draw us another client. Okay, and our client is still running JavaScript. Okay, we've got the JavaScript part, the browser part that is going to implement WebSockets. We are going to use Socket.io to do the WebSocket part. It opens up a connection just like up here. The difference is it is going to use TCP to do so, and that connection is going to remain open. What is the advantage here? Well, if either side has something to say, you just say it. And you can remember, it is a stateful connection because the connection remains open. You can maintain a relationship, an ID to that particular session. A lot of variables and whatnot can be shared across the connection because it remains open. Unlike HTTP, which again, you make the connection, you fulfill the request, and then you are done. Here, this stays open until it's explicitly closed. This one is maybe like maybe a conversation with a stranger that you just meet in a park or at a random place. You give them one sentence, you say hello, they say hey, hello back, and then you pass on. And then if you ever run into each other again, you're gonna have to start over because you didn't really meet them. Unlike HTTP, TCP is more like a phone call where you pick up the phone, you talk, and you can talk for 10 or 15 minutes. Even on this video, you remember the things I said 2 or 3 minutes ago. I need you to because the conversation sort of builds on itself, right? If I need to say something on the phone, I say it. If you need to say something, you say it. This is a big win because with HTTP, the server cannot push out to the client. It would not be safe. For a lot of reasons, the server could just randomly pick a browser somewhere on the internet and send something to them. You have to have special software to manage HTTP requests, and that's a big drawback if we need to push something out. Okay, because in the case of like a chat app, you're going to have clients all over the place, and this person maybe sends something up. With HTTP, we don't have a way to pass it out to everybody. Hey, there's a new chat message. We need to wait until they ask for it, and then we could send it out to them. If we are connected via TCP, so the message comes up, the same thing, all of these clients will have a direct connection that is open. As soon as that message comes through and hits the server, we can pass them all out on a real-time type basis. So this is kind of the difference here. Is HTTP is request response, and usually that's what you want when you're making a web app. But sometimes you need bidirectional, meaning you can go both ways. The server can send stuff out to whoever needs it. The low latency part, that is kind of like the real-time part. Low latency means there's almost no delay. It has a really small amount of time required to send stuff out. So low latency could refer, I guess, to the network. The overhead is low, but it also would mean it's essentially real time so that everything can be passed out pretty much immediately. The every platform thing, I'll let you decide if that's true. You can go check out some of the other libraries if you want to use them. But this is the gist of how it works. And the applications, yes, a chat message. But what if this were a video game? What if you're playing a video game and so is everyone else, and everybody has stuff going on? They're going to push it to the server, right? This is where my character's at. This is what my character's doing. And then the server needs to send out to everybody. This is where everyone else's character is at and what they are doing. Or maybe you have a web app like a ticketing system where everybody's looking at different seats in an event, and this person grabs a particular seat and pays for it. You need to let everybody else know, hey, that seat's not available anymore, or the prices have gone up, or whatever it happens to be. The server needs to communicate in real time, low latency, and it needs to be able to push stuff out to the various clients. You can't do that with HTTP unless you use long polling, which is actually what Socket.io falls back on. We'll talk about that a little bit later. Let me clean this up quick. So let's pull up the documentation here for WebSockets, because as I said, this Socket.io is built on top of WebSockets. So we need to unpack that here before we move on. So let's pull up the docs here. Got MDN open. It says the WebSocket API is an advanced technology. Okay, let's pause there for just a second. Feel good because you are using an advanced technology. I always think that that's kind of a fun thing. That makes it possible to open a two-way interactive communication session between the user's browser and a server. So you can send a message to the server and receive a response that are event-driven without having to pull the server, okay? So if we compare the two, it said two-way interactive communication. That's the bidirectional part. They don't really have they used to have a pretty clear comparison with low latency. They don't anymore. But WebSockets are use TCP. Okay, it's the same thing that we talked about with Socket.io. So they kind of are doing the same thing, right? Well, they're kind of doing the same thing because they are doing the same thing. As I said already, we are going to talk about Socket.io. This is a library, and the library is built on top of an existing API, right? The underlying technology is the WebSocket API, okay? And this is, I'm going to put here, the client portion. JavaScript, the browser, I'll put that here, browser, is what uses WebSockets. They are not a thing on the server, on any server. Node.js has a WebSocket node module, but the server doesn't know about the WebSocket API because WebSockets are a browser thing. It has network sockets, and it knows how to connect to browser WebSockets, but no server knows about WebSockets. It doesn't care. It's Node.js or it's Python or it's Java or whatever. The WebSocket API is a JavaScript thing. It's a browser thing. So the client portion of Socket.io uses WebSockets pretty much all the time. As I said, back in the early days, like 2009, 10, whatever, you had coverage on like maybe 40% of browsers. So if you were going to implement WebSockets, have a chat app like this, there was a good chance it wasn't going to work on the browser that was running it. So Socket.io did something called long polling. This was one reason why you needed to use it. In fact, I would say it was the main reason in the old days. What long polling is, so if you remember with our HTTP example, we have our client machine and we have our server. And if we can't connect via TCP, you have to send a request over. And so the way that long polling works is you send the request until one side has something to say. If this side has something to say, it sends a new request. Otherwise, the server just waits, and if and when it has something to say, then it will send a response. This will terminate, and you will immediately open up a new request. So long polling is essentially just there's always a request, an HTTP request open, so that if the server needs to send something back, it can. Now this worked, but it was a terrible model because there was so much overhead. You always had this HTTP connection open. They timed out after 2 minutes or whatever the network allowed. This was not a great model, but it was something that we needed in the old days because WebSockets didn't have good support. They do now, but still sometimes we do need long polling because a proxy is misconfigured or a firewall simply won't allow TCP connection or something like that. So Socket.io uses WebSockets, but it also adds in long polling. In addition to that, it also adds multiplexing, and this gives us the ability to use rooms, although that's not maybe the fairest example. Namespaces are the easier example, or the true example, but rooms are a little bit easier to understand. When you create the connection, so we'll switch back over here to TCP. So we've got our client here. It's going to connect to the server via a WebSocket. You might need more than one connection to the same server. So we'll have, it'll be like that, where maybe one is connecting to /admin and the other is connecting to /general, right? You have two completely different namespaces, different sockets or different WebSockets that you want to communicate with. Socket.io has that ability, and it uses multiplexing, which means you can use the same connection to manage more than one sort of room, right? Like admin in general. Again, it's namespace. It's just, it's semantics. If you're new, if you know how it works, then you know how it works. With WebSockets, you'd have to have two separate connections, at least as of the making of this video. You can think about this like a phone line. If you've got a telephone pole outside and the phone lines that run from place to place, you don't need 1,000 phone lines for 1,000 individual phone calls. That one phone line can manage 1,000 different phone calls at the same time. That's what multiplexing is, and Socket.io gives the ability to manage multiple namespaces or rooms, so to speak. It also has a reconnection feature that, as of the making of this video, WebSockets doesn't have. Now, maybe it will when you watch this, but it's very possible, and it goes a little bit farther. I'll put in here, though. It has a heartbeat. Both sides of this connection will keep track to make sure, is the other side still there? Because with WebSockets, it's possible to get disconnected and the other side has no idea. So it's still sending events and listening for events, but there is no more connection. Socket.io has a heartbeat to make sure that both machines are connected. And if they're disconnected, it will reconnect. Another benefit of that is packet buffering, which is a fancy way of saying if there is a disconnection, then whichever side is trying to send data, it will hold that data in a queue and will send it in the correct order when the reconnection is established. There are a few other things, but I want to keep moving here. The point is, Socket.io uses WebSockets. You could use WebSockets by itself and get this connection, get the TCP, get the low latency, get the bidirectional, etc. But All of this other stuff is what makes Socket.io so valuable. You're going to end up probably having to make this stuff. Maybe you have a fallback, maybe you need rooms, maybe you need a reconnect feature with a heartbeat, maybe you need packet buffering. And you will have just made Socket.io yourself, and that is silly. There are some phenomenal developers that are working on this that are probably better than you, or at least there's lots of them if you're awesome. It is also battle tested across the past 15 years or whatever. So Socket.io, in my opinion, in 2024, or whatever year you're watching this, still makes sense. Instead of WebSockets, you're using WebSockets, you're just using WebSockets Plus. That's kind of how I refer to Socket.io. Let me clean this up again real quick. I have a video that goes over the reasons why you'd use Socket.io over WebSockets. It goes into more detail. I will link that in the description if you want to check it out. The TCP thing, I love talking about network packets and how things work under the hood from a developer's perspective because it's something that so few developers are ever exposed to. I have several videos that kind of go into more detail. I will link those. Please check them out if it's interesting. What I will say about where we're at is this. When you send a packet across the wire, right, across the cables, there are two different models. I'm using the 5-layer model, but at the very top is the application layer. Right underneath that is the transport layer. I'll go ahead and finish them off. We have the network layer, we have the link layer, and then at the bottom we have the physical layer. Not going to go into detail right now, but what matters here is network is going to be internet protocol. Right above it, transport is TCP and UDP. These two things together, TCP/IP, create the internet suite, which you probably have heard of before, TCP/IP. The application layer is going to be things like HTTP, which we already talked about, FTP, SMTP, and so on, right? Various protocols that handle things at an application level. Application, HTTP, is built on top of the transport layer. So when you make an HTTP request, you're using TCP to get to the other machine. Once that's been established and the HTTP response is fulfilled, you drop the connection. In the case of WebSockets, we don't necessarily have to use HTTP. We can stop with TCP, but you can also make the connection by piggybacking on an HTTP connection, which is what I typically will do. I'll make an Express server and we'll use WebSockets or Socket.io to listen on that same port, and then the server can sort of sort things out. But again, we are going to be working at this level rather than at this level when we do Socket.io. And the important things to keep in mind before we start coding: one, there are two pieces, right? There's JavaScript on one side, there is a server on the other side. You probably already have that down, but just make sure you keep it clear. And two, this is event driven. So instead of the browser initiating, the server responding, the line is open and either side can talk anytime. It can get really confusing because you don't know when the other side is going to say something. If you've got a whole bunch of different clients connected, you have to keep that in mind. It's a very different model, but it is so fun and so much power behind it. Okay, let's hop over to our code editor. Let's start coding and see how this works. We are on to the coding part. This may be what you were waiting for, but it is broken up into a couple different sections. The first thing we're going to do is I'm going to just walk you through my setup here, the files and how I do things to make sure we're on the same page. And then we are going to make a Socket.io server together. We will just code it out, and you'll just have to watch me. I will explain as we go. I don't like doing that. I prefer showing you the docs, but we got to start somewhere. Once we get to the point where we are connected and we've done a couple of the basics, we'll go over to the documentation and we will look back at what we did. And if you don't normally look at the documentations, I get it. I know it can be a grind and it can be boring and you just want to code. But the goal here is for you to be able to use Socket.io in your own projects and in your own stuff. And the only way you're going to be able to do that is to know where to look and to know how to read the manual. So that is a very important part of the video. And once we get finished with that, we'll come back over here to our code editor and we will finish making it look and work like a chat app. And then I'm going to take you through at the very end a project that I've already finished. I will give you the code, a link to the code where you can follow through with me. It is an online game. I want to be able to show you more of what the API can do, more possible use cases for Socket.io, and I can't make you an expert in an hour or an hour and a half, so that's a way to kind of bridge the gap. So again, we'll go over the setup, we will code out a server, we'll go over to the docs and look and see what did we actually do, and then we'll finish up the app, and then we will look at another project, the online game. So I've got Visual Studio Code. Any code editor you want to use is just fine, but I've got a folder called Socket.io Explain. Call yours whatever you want. Inside of it, I have server.js. This is going to be our node server or our Socket.io server. I have a folder called public, and inside of public, I have index.html, and this has just the Visual Studio Code boilerplate. You don't need to put this if you don't want to. The easiest way to get it is to just do an exclamation point and hit tab, and it will drop it if you use Visual Studio Code. But I have linked styles.css and scripts.js. So those are our two files. Scripts.js is totally empty. Styles.css has just a few styles in it to make the chat app look a little more tolerable once we get there. So you can grab this out of the repo. The link will be in the description. You can write your own, whatever is just fine. Okay? So we are going to start on our server, and to do that, we're going to hop over here to the terminal. I'm also on my Windows machine, which means I'm using PowerShell for my terminal. That should be the same on Linux, on Mac. The only reason you might have a slightly different command would be if you are on an old Windows machine and you're using the old command prompt or terminal. If that's where you are on your own, and I strongly suggest that you upgrade to PowerShell because it is very much worth it, very, very much more powerful. The first thing we're going to do, make sure you're in your root folder here. We're going to do npm init-y, and that will get us a package.json file here to work with. So here we go. We need to add a couple dependencies, and we will do that with npm, whoa, not sure what that was, npm install socket.io, and let me get that onto one line. There we go. So socket.io, this is the whole thing. It will come with the server and the client files. If you're in a situation on the road where you just need the client files, there is socket.io-client. We are also going to need Express, so please npm install Express. You will see why here in a minute. And when you are all set, please run, I'm going to do nodemon on server.js. If you don't use nodemon, check it out. It will automatically restart the server every time we make a change. Right now, our server is doing absolutely nothing. So let's hop over and fix that. So we will start off by bringing in Express, and we will require Express. That is the module we just installed, and we will do const app. We will invoke Express, and I'll put a comment here, make an Express app. The reason that we are getting Express, we'll do app.use open close. We're going to do express.static, and we are going to hand that public. We need a way to serve up the index.html, the scripts.js, and the styles.css, and that is going to be Express's job. That's what this will do here. And we will drop in here app.listen. I'm going to do port 4000. Pick any port you want. It is totally arbitrary. I'm just in a 4000 mood, I guess. And I'll drop a comment in here on line 3. Serve the files in public statically. Okay, this gets us into position where we can at least hop over to index.html. Make sure that you are all caught up here. I'm going to drop in an H1 and say Express server is working. This is just a basic sanity check. We want to make sure back over here we don't have any errors, and you can see nodemon is restarting every time I save. We want to make sure we don't have any errors, and we want to make sure we see this H1. And here we are, localhost 4000, Express server is working. So make sure you can get at least here so you are ready to move forward. We are going to now come over here and we're going to do const socket.io equals require socket.io. So that's the other module that we installed. It's right here in this variable. We are going to make a variable called IO, and this is going to represent, I'll go ahead and put that here, IO is our socket.io server. The reason I call it IO is because that's what they do in the documentation, or at least they used to, and it's just habit. You can, of course, call it anything you want. But I'm going to grab socket.io, and we're going to do open close. and we are going to hand it, well, we need to hand it our HTTP server, and that's line 5. We can't hand it app because that's going to be a callback or a function. So we're going to do const, let's call it express server equals, and we're going to get the return value of app.listen. That will be the actual HTTP server. So on line 9, we're going to hand our express server over, and then we're going to hand just an empty object here, which will be our options eventually. Alrighty, that right there will get us a Socket.io server. So we're going to go over to index.html now. You can hop over to your terminal, make sure you're not getting any errors. That is no fun to code a whole bunch and have a bunch of errors in your wake. Make sure you've got scripts.js loading up. Right above it, we are going to drop in another line. We're going to put in /socket.io/socket.io.min.js. This file is being served up. If we come back over to our server, it is being served up right here. This thing is going to make it. We'll come back to that. But this will put the IO object in our client. So just as a test, I am going to log line 1, our IO. Come back over to our browser and refresh. And on line 1 here of scripts, this is the IO object. I'm going to make sure it looks something like this, maybe not exactly. But we have two parts. We have the server. This is the Socket.io part. We talked about that at the very end of the whiteboard session. And then we have the client. So these are the client files. That's what's going to run on the browser. This is our node server that's going to handle the Socket.io traffic. This is sort of that center for all of the individual clients. We have the IO object. Come back over to index.html because this is putting it in the global scope. It's adding it to the window object. Okay? When you are ready, come over to scripts. We don't need this line anymore. And we will do const socket equals IO. We're going to hand it http://localhost and then whatever your URL happens to be of your Express server. Because the IO or the socket server is piggybacking on the Express server. So this right here, if all went well, you shouldn't have any errors over here. And if we come back over to the browser and refresh, you don't have any errors down here. If that's the case, even though you can't see anything yet, that means something good happened. And what we'll do is come back over to server here, and let's drop in our very first thing. We'll do io.on. And make a note here. On is a regular JavaScript /node event listener. We'll see that in the documentation, but IO is our socket server. So anytime you see IO or whatever you called it, we're referring to the whole socket server. We're going to listen for an event. What event? We're going to listen for the connect event. If that happens, the second thing that we hand it will be a callback, and we call the thing that we get socket. So this callback is going to run. If you prefer, it can look like this. If you're still kind of pre-ES6, it could be this as well. Any of those, they're all going to be the same because we're not going to use this. I prefer to keep it nice and short like this. We get socket when it connects. Connects to what? Our IO server. In here, let's do console.log, socket.id. Let's go a little bit further. Let's do socket.id, comma, has joined our server. So if someone connects, right? What connects? A socket connects to what? Our IO server, right? On connect. This code, line 15, will run. Why would that happen? Well, over in our JavaScript file, we are using the IO object, and I'll make a note here. IO open close connects to the socket IO server at the URL. This is going to make our connection. The reason we have the IO is because in index, we brought it in right there. The reason this is here is because when we started up our server, it started running. The moment of truth, if we hop over to our server, all right, the terminal should hopefully show this in here, that you've got whatever socket ID has joined our server. And I misspelled joined. Sorry if that is bothering you. It was not on purpose. We have made a connection, and this is going to be pretty much the same in every Socket.io app that you have. Now, you don't have to use Express. We'll come back to that. But we're using Express to serve up our files. we've made our Socket.io server, and we're listening for sockets to connect. Inside here, we can do one better. I'll make a note. Emit is the other big method, and I'm going to move that up top here. This one actually goes there, but I've got emit is the other big method. It comes second, I guess, in order. We can do socket.emit, open, close, so this is a method. This is going to send an event. So on listens for events, emit sends events out. Who are we going to send it to? We're going to send it specifically to the socket that just connected. Okay? In that first argument, I'll make a note here. First arg of emit is the event name. This can be pretty much anything that you want it to be. The second thing is going to be the data that we want to send over. I'm going to send over an array with the numbers 1, 2, and 3 in there. So this callback, this callback is going to run on this event. We're going to get this log, and then we are going to emit to the other side. So we go over to scripts. We've got our socket. So our socket has an on method and an emit method. Those are the two big ones. Let's drop them down a line here. It has an on method and an emit method, just like on the server. So let's put that in there. Just like on our server, our socket has, there we go. We can put in here socket.on, listen for the welcome event. Just like on the other side, the first argument is the name of the event. What are we listening for? The welcome event. So on welcome, we're going to run a callback. So I'll have data, and we will just console.log data. If all goes well, we'll have to refresh because this is a new thing on our browser. Data will come through as an array of 1, 2, and 3. And if we come back over here, every time I save, the server's restarting. Let's go see if we got line 9. Quick refresh, and there we go. It is coming through. So what we've done is we did our initial connection, our handshake. This initiates the connection. This is listening for it. And then we are sending via TCP. So this is real time. We are pushing an event. Push an event to the browser or the client, whatever, client is more generic. Socket.emit does just that. Now over in scripts, we're listening for that event. We can do the same thing. We can, inside of welcome, once welcome is emitted from the server, we run this callback. Let's put in here a socket.emit. So we're going to send an event back to the server. We'll call this the thank you event. And we'll send back over, let's do 4, 5, and 6. This is going to do the exact same thing, but from the client side. So this is just like a phone call. This is listening to the other side, and this is saying something. Both sides can do it anytime they want to. Come back over to the server. We're going to put this inside of our connect. You can save things differently, but typically you are going to add your listeners inside of the connect method because that's where you have access to this particular socket. We will come back to that in the documentation, but socket.on, we're going to listen for the thank you event. We're going to get data just like we did on the other side, and we will console.log it, message from client, comma, and we'll throw the data at the end. So if all goes well, we will see 4, 5, and 6 on this side. Come back over here. Let's refresh. Back over to the server. There we go. I refreshed a couple times by accident, it looks like. But everything's happening is so fast, we can't really trace it. But we're getting our connection. This is happening inside that listener. We're getting our message from our client. Why? Well, as soon as they connect, we send welcome out. Back over in scripts. Meanwhile, before we go over, we're going to listen for thank you. Whenever it happens, it happens. If it doesn't, it doesn't. Over in scripts, welcome will have just happened. This callback runs, we log the data, and we send back over the thank you event, which has 4, 5, and 6. So I hope you're seeing what's going on here. We can push and we can listen from both sides anytime we want to. The server, meanwhile, has gotten this event. So let's hop over to the documentation and try and make some sense out of everything we just did. And I really encourage you to watch this because this will be very, very helpful. If you hover over top of the docs and click on guide, all of the stuff over here. There's a whole bunch of different topics. It is really, really useful. Now, it's not casual reading. You won't just want to read through everything. But over time, this will be a good place to come. I think I've read all of it, and it is almost all worthwhile. In the introduction here, we already talked a little bit about what Socket.io is. We scroll down a little bit. The server implementations, remember the any platform, it's not any, but Node.js, that's what we're using. We have another implementation, and then Java, Python, there's actually two Javas, Golang, and Rust. And these two are managed by Socket.io. These are managed by individuals, by community members. So just be aware of that, but they should work if you want to use it in another language. The client implementations, this might look a little bit strange, but the browser here, that's what we're using. We're using the client implementation, which is coming with our server. But you can make a Java client. So you'd have a Java server running that would be acting as a client connecting to a server. So a whole bunch of Java clients or C++ clients, etc. So just something to be aware of. What Socket.io is not, it is not a WebSocket implementation. So just make note of that here. If we hop back over to our client, this line will not be able to connect to a WebSocket server on the other side. And if we go over to server, this will not allow a WebSocket connection from the other side. You will see a little bit later, you can use the WebSocket protocol, but you can't make a new WebSocket and connect because it's not a WebSocket implementation. They just got some notes here. For that, you would use WebSocket, which Socket.io uses under the hood. We'll see that in a little bit. Okay, keep going down. Under features, this is all stuff we talked about on the board. You can kind of look at this a little bit closer if you would like to. Gonna click on how it works. A few things here. Socket.io is broken up into two specific layers. The first one is Engine.io, and Engine.io handles the low-level connection between the server and the client. It says here the low-level plumbing. That means that it handles the transports, and if I click on that, there are two transports that come out of the box. There's HTTP long polling. That's the part where we send an HTTP request, keep it open until the server responds, or we need to send something. WebSockets is where you're almost always going to want to go to. That's kind of the point of this whole thing. But Engine.io manages those two things, as well as the upgrade mechanism. Out of the box, it's going to use HTTP polling, long polling. It does take a little bit of time to establish the WebSocket, and so this is kind of a nicety in between to give the user a good experience if there's a delay in the WebSocket connection. So that's thing one for Engine.io. Thing two is the disconnection detection, which we talked about. There's the heartbeat, and then all of this stuff, just trying to determine has one side lost the connection, and if so, that's Engine.io's job. You're probably not going to interact with this until you get really advanced. I very seldom make changes to Engine.io. There are some things in the API, which we'll see in a minute, but for the most part, what we interact with, so that was part one, mostly what we interact with is the high-level API, which is Socket.io. And we will be over there in just a second. Okay, so you could look at all this stuff if you would like to, a little more detail about what Socket.io does, but it's just the features we saw on the last page. With that, I am going to hop over to the server API, which is this page. And they've got a nice diagram here, which you can check it out. They've got the Engine.io, which we just talked about. But let's look at how our code actually worked. The very top here, the constructor, and over here, the server, capital S server. The constructor is how you make a Socket.io server. And there are three different ways to do that. We did the first one where we did new server and we handed it an HTTP server. So back over to our code, we made an Express server right here, line 5. This is an HTTP server. That's what Express handles, HTTP traffic. Line 9 here, we called Socket.io and we handed it our HTTP server. That is what we've got here. You can second argument pass it some options, and we'll look at those in a second. We scroll down a little bit. Another way you can do it is you can simply hand it a port. If you don't need HTTP, and in our case we do because we need to serve up our static files, but if you don't need it, you can simply hand it a port. And you can use, there's a server object that comes directly out of the Socket.io library. You can grab that. The last way down here, if you don't even have a port, like out of the box for some reason, you just want to get the server going and add it later, you can just give it options. And then down below, you can see there's an io.listen, whereas up here, you don't have the io.listen. You gave it the port when you started it. Okay, so those are the three different ways. What we did was this first way, where we handed it our server and we handed it our options. What are the options? Well, right here, this line will take you to this page. And there's a lot more here than we're going to be able to cover. I just want to make you aware of a couple of things. The adapter. This is a bigger concept than you probably need to worry about right now. You almost certainly will not use a different adapter than what comes out of the box. The in-memory adapter is the default value, which is socket.io-adapter. If you click on adapter, it will bring you to this page. And the adapter is a server-side component which is responsible for storing relationships between the socket instances and the rooms. We haven't talked about rooms yet, but you can think about it like you maybe have, back over to our code, if over in scripts here, we make one connection with the socket, we might on the server want to add that socket to two different rooms. Maybe the game room, and that will be broadcasting all the messages about the game. Here's where all the players are, here's what they're doing, here's their inventories, that kind of thing. And maybe there's a chat room, and that's where you're broadcasting all of the different messages to different players. The adapter is in charge of managing that stuff, and it's also in charge of broadcasting events to all or a subset of clients. So again, if you happen to have a socket or maybe 50 sockets in the game room and you've got 1,000 connected to the server, you only want to send out to 50. That is the adapter's job. And again, the in-memory adapter is what you'll be using out of the box. As you get more sophisticated, you might want to use Redis instead of in-memory because Redis might perform better. If you get to the point where you're going to use the cluster module, you'll want to use the cluster adapter. The Redis adapter will work with it. I think eventually through some of the upgrades, it's been a little bit bumpy lately, but you get the idea. The whole thought here is that the adapter manages how you broadcast to different clients. And here are your options if you wanted to use MongoDB or Postgres to manage that, or Redis, etc. Okay, so that's the adapter. We keep scrolling down here. The path, the default value here is /socket.io. This is the name of the path that's captured on the server side. So if you want to access something over there, back over to index, the reason that this is socket.io is because the default path is socket.io. If you wanted to change it to something else, you could. Scroll a little bit farther down and we have serve client. This defaults to true. If it's true, then it gets served up. Well, we've already talked about that. Socket.io.js, .min.js, and then the package here, they get served up if this is true, and by default it is. If you come back over to your server and we drop in our object here, I'll put in false, so it will stop serving that up. Back over to our server and refresh, we get a 404 because it's not being served up, and then we get an IO error because it was never added. So I'm going to get rid of that. Back over to our options. Some of the engine options to take a look at. Most of these you'll know if you need them, but the cores one is going to be the most common one that you probably will need to add so that you have access, or so that you can limit access. The default value here is dash, which means nothing will be allowed. Now we are okay because our server is running on localhost 4000, and so are the files. So we don't have a cores issue. But if you were running, say, a React app on a different port or a different URL connecting to an API, you would need to add this in. So as a quick, for instance, here we'll do cores, open, close. It is an array, and I'll put in here right now localhost 4000. Hopefully you know how cores works, just to handle cross-origin requests. But this is an important one to be aware of. Going a little bit farther down here, let's actually over here on the right-hand side, I'm going to click on, let's start with ping interval. This is set to 25 seconds by default. This is the heartbeat mechanism, which will check if the connection is still alive between the server and the client. It's going to be a little bit a matter of taste how low or high you want this, but this is out of the box what it is. The ping timeout is how often it will try and reconnect. Which by default is 20 seconds. The transports, the default value is going to be polling, so start with polling, and then upgrade to WebSockets. If you switch the order, it will try and do WebSockets before it does polling. I would say this is probably important to keep unless you have reason to change it. The last one we'll talk about is the WS engine. Out of the box, this will use the WS module. And if I hop over to NPM here, the WS module, one thing I love about it is it has 0 dependencies. 17,500 different modules do depend on it though, one of which is Socket.io. And you can see here 65 million weekly downloads. So this is a crazy important node module for the internet. I don't know why you'd need to use something else. If you're in a situation where you do, this would be how you would do it, is with this option. Okay? So that is the constructor. There are 3 ways to make a new Socket.io server, sort of. As I'm sure you noticed, we didn't use any of them. New server is not in our code. Line 7, we require Socket.io and we store whatever it exports in Socket.io. And then line 9, we just invoke Socket.io. So we should have this based on what the documentation is saying, but we got away with this. Why is that? Well, just a quick side note. If I open up node modules and I go down to Socket.io here and open it up, go to dist and index.js. This is what we are requiring when we require Socket.io. I have scrolled all the way down to the bottom of the file here. Line 785, exports.server equals server. Well, coming over here, the reason that you can import server, they're destructuring it from the Socket.io module, is because of line 785. Scroll down a little further here though, the default export, meaning if you don't ask for a particular object, it's going to be this callback. This callback that expects a server, expects options, and is going to return a new server with server and options passed to it. They are doing this work for us. I don't know if I am a relic and I'm just doing things the way they've always been done and I'm supposed to update and the documentation is trying to say that, or the documentation has updated itself, but this still works, or rather, I guess this still works, because they are still on line 797 here doing a module.exports and they're sending it out. So we can do this. I'm going to leave line 7. I'm going to do const server equals require Socket.io. So this is how they are doing it. The way the docs make a server. Actually, let's say the object the docs use to make a server. And then down here, instead of line 10, I'm gonna copy this and comment it out, and I'll paste right below it. Const.io equals, instead of Socket.io, it'll be new server, just like that. Everything is exactly the same. I just swapped out the default export with new server. If we come back over and refresh, everything works as it should. So this is just maybe a little tutorial on how node modules work, but that's why this works. And I want to make another note while we are here. We've got IO is our Socket.io server. I'm going to make another note here. Capital S is the server constructor in the docs. It's the top thing. Small s is the variable in the docs for the server. We call it IO. Let me show you what I mean, because this is easy to get hung up on. Capital S server up top here, that is the constructor. That is what we are using to make lowercase s server. All of these lowercase s's over here are the actual variable names. So if we go to server.on, which is right here, they've got server.on. That is, again, the lowercase s is the server we have made from the constructor. Down here, they have actually called their server IO just like we have. So server here is a generic name for, hey, this is a Socket.io server that came from capital S server, the constructor, but the variable name is IO in their example code. The same thing's true over here. We have now grabbed the capital S server. We made a new server, lowercase s, but we called it IO. And we've got that line here. The small s is the variable in the docs for the server, but we call it IO. So to illustrate this a little bit, we've already got a little bit of code down here to help out. We have an IO.on connect, okay? Connect to what? IO. What is IO? It is the server. That means the entire server is listening for a new socket to connect. Down here we have a socket.on thank you. Okay, if the thank you event happens, on what? On the socket. So this belongs not to the whole server, but to an individual socket. These are two different listeners on a connect event to the server, on a thank you event to a particular socket. Right here we have emit on a socket. That means emit to this particular socket. So socket.emit will emit to this one socket. If we put right below it io.emit, we'll do hello all, and we'll send out with the string hi inside of it. This io.emit will emit to all sockets connected to the server. Again, the server lowercase s is our variable io. Hopefully that makes sense. We've got two different types of emits here. We got two different ons. Over in scripts, we only have one option because the socket is connected to the server. It doesn't know about any of the sockets, so it only has an emit to the server and an on from the server. Socket.on, on what? On this socket gets the welcome event, socket.emit. This socket is going to emit out to everybody. We're also going to listen to socket.on, hello all. That was our event right here. We are going to run a callback when we get that. We will console.log message. Let me scroll down a little bit here. Message to all clients, comma, and then I'll just drop the data in there. So if we refresh, we get line 9, which is that initial welcome event, and then we get line 15, message to all the clients. This, we only happen to have one client because I've only got one browser window open. If I grab another, so this is a new incognito window, I have dropped it in. All right, you'll notice two things happen. One, we got the same stuff over here. We got that again. Why did this happen again? And I'll refresh, watch over here. Okay, it showed up a third time. In server.js, anytime someone connects, we send out a message to everyone. So let's change this from hi. Actually, let's change our event name from hello all to new client, and we will send out a message. Let's do the new socket.id. So this is the ID of the socket that just joined. If we come over to scripts, so instead of hello all, it will be a new client. Message to all clients, a new socket has joined, and we'll post the data there. That will be that socket ID. So we grab these two again. I'm going to refresh. Okay, message, a new socket has joined. That's this socket ID. If I refresh over here, okay, this socket didn't get the first message because it wasn't here yet. Over here, we get the new socket has joined. If I copy and paste this in again, the third one has popped up now. We can use pretty much any event name we want. So you saw me use new client. We had hello all. We have welcome. We have thank you. They have an emit cheat sheet here. It's this URL if you want to go to it. But these are the only things you cannot use. You cannot use connect, connect air, disconnect. These are reserved for Socket.io already. So here on line 24, the first arg or emit is the event name. Anything is okay except for what is here. I'll drop that URL in so that you'll have it in the code base if you would like it. On the server, again, the events right here, there really are only two that you need to worry about at the moment. There's the connect event, which is a synonym or an alias of connection. We used connect. It is exactly the same as that. They do the same thing. It's just legacy code that's being incorporated. Past events is attributes. You can look at those if you want to. The methods, there's so much good stuff here, and these can go a long ways, but there's way too much to talk about. For starters, what we are interested in, as we've already talked about, server.emit. So this is io.emit, means emits an event to all connected clients in the main namespace. Down here, there's a server.emit with ACK. I'm not going to show you this up front because I don't want you to abuse it, and I want you to I think it's important to get familiar with the model. If you need a response from the other side, meaning send me some data back, kind of a request response type thing, they show you an example. Instead of just emitting it, once it is done, it can send a variable back to you or whatever piece of data you want, and you can store it inside of a something. Again, I'm not going to show you. You can follow the example here. You cannot run code that is on the server on the client, and you cannot run code that is on the client on the server. That is not possible, and thank goodness, that would be so dangerous. What you can do is send a variable back, and that's what emit with acknowledgement does. Same thing as emit. You can send a variable inside of that event. The on event we already talked about, server.on. This means the entire server is going to be listening for events. And then we are going to skip over namespace and go down to socket, capital S. So just like we talked about with server, socket, capital S is the constructor. That is a socket thing. We make a socket, and it is lowercase s all the way down the list here. So inside here, capital S in the docs for socket is the constructor. Lowercase s socket is an individual socket. And it is going to be scoped to connection unless you store it somewhere to add events or listen for events later on. Pretty much the same stuff here. We've got a socket.emit. There's emit with acknowledgements. Down below there is socket.on. There's socket.on any. You can look through those, but we've already pretty much talked about it. It's really just who are you interested in. If we go back up to the top now and look at the client API, we don't need to spend much time here, which you're probably glad about. This is pretty much the same stuff over on the other side because the client and the server, they're intended to function largely the same way. The difference is this only knows about itself. It doesn't know about any of the other clients. You make a socket, and the IO method, to get there, the IO method, it's added to the global scope. We already talked about that. You can include it directly, but by including the script here on index.html, that's how we have the IO thing here on line 3. It's bound to the global scope. You can get it all these other ways, but the way that you make a connection is with IO. You can optionally pass a URL and optionally pass options. If you don't pass a URL, you're going to have to tell it what to connect to later on. But this is all pretty much the same thing. You store whatever it returns in typically a variable called socket, and that is the thing that is going to do .ons and .emits. Briefly, looking at some of the options, we don't need to go over these like we did in detail the other ones. Look down the right-hand side here. What is useful is the query. The query is what gets sent through the URL when you make the connection. And it is inside of socket.handshake. So socket.handshake.query. And then at the very bottom here, there's an auth. Auth is not sent through the query string. This is where you would pass sensitive data like a token or a password or something like that. So if we come back over to scripts, we put an option in here, and I'm going to put in auth is an object with a property of secret. This is a secret. And then below that, I'm going to put a query meaning of life 42. This is going to be a variable in the URL, just like you're used to hopefully with query strings. This is not going to pass in the query string, but will be available in server. In the connection, I'm going to console.log socket.handshake. And there'll be two things in there. It'll be the query and the path, among other things. We need to refresh our browser, so we send it up. Back on the server. All right, here is our handshake. The headers, these are all the HTTP headers you can look at. Here's our query property. The meaning of life is 42. That's from Hitchhiker's Guide to the Galaxy, if you don't know it. It's a really silly book or show. This came through the query string. You can see it right there. Socket.io. Question mark, meaning of life equals 42. EIO is the version of engine IO. Transport mode is polling. And then T equals this brief hash. The auth does not come through in the URL. We have secret, and this is secret. This is where you would do authentication if you needed to. And if they don't pass authentication, then you could disconnect them with socket.disconnect open close. Back to the client API, the IO returns a socket as you've already seen. We store a socket in the variable socket from the IO. What it actually creates is a manager, and you can read about the manager if you want to. We technically could make a manager and then grab the socket from the manager, but that is not usually going to be necessary. You're not going to need to interact with the manager very often, but if you want to look at it, at what it does, you sure can. With all that out of the way, let's make it behave a little more like a chat app. I am going to include Bootstrap. If you don't like Bootstrap, you can grab something else. This is just a fast way to make it look better. I'm sorry if it's not cool when you're using it. This is all I need right here is the CSS from the CDN. Gonna paste it in right above our styles.css, and down below here, get rid of our h1, and we will make a div with a class of container and text-center. So this will be our wrapper class around everything. We will make a form with a class of row to make Bootstrap happy, and an ID of messages-form. That one shouldn't matter what you call it. Some of these will be CSS specific, so if it doesn't look quite like you think it should, just consider the classes or the IDs. Make a div with a class of call-6. Inside this, let's put an input with a class of Inside this, let's put an input with an ID of user-message, type equals text. We'll put a placeholder in here of enter message here, and then close off our input tag. So let me shrink it down a little bit so you can see it. There we go. So that's line 16. We'll make another div with a class of call-2, and inside here we'll put another input with a class of btn-primary, that's a Bootstrap thing, a type of submit, and a value of send message. So this will make us a 2-column with input box. And then outside of our form, we'll have another div with a class of, let's do call-12. We'll put in here a UL with an ID of messages and a comment starts empty, populated by socket.io and JavaScript. That is our entire DOM. You can take this much farther if you would like to. We've got our messages form over to scripts. We are going to add an event listener, and I'll put this at the very bottom. We'll do document.getElementById, go looking for the thing with the ID of message form, and we will add an event listener. What event listener? A submit listener. What should happen? We'll run a callback. We'll grab the event. We need to prevent the event from happening, so e.prevent default open close const new message. We need to grab what is inside of index.html. It will be this thing. So this is the message that the user has added. So the new message will be document.getElementById, grab the thing with the ID of user message, and grab its .value. So we know what the user put in there. Let's then immediately turn around and clear this out. So we'll set that equal to empty. So that means we've stored what they put in this variable, and then we cleared out the input box, otherwise it would still be there. And we will do socket.emit, open close. Let's make a comment. This socket is sending an event to the server, ... What event? Let's do message from client to server. It couldn't be much more descriptive than that. And we will send our new message like that. Okay, over to the server. So we always need an event listener on the other side. I'm going to comment out this extraneous stuff because we don't need that anymore. We're going to do socket.on. So we're listening for this particular socket. Which socket? Well, every socket that connects will get these. We'll have this callback running, means they'll all have this listener. We're going to listen for, we'll call it new message on this side as well. The only thing the server really needs to do here is pass through the message to everyone connected. So that means we'll do an io.emit. Let's call this one message from server to clients. In fact, let's do all clients just so that you're clear on what's happening. We're going to send new message. So the client sent this, and that message, that came from one socket, the server is going to turn around and emit to everyone whatever was just sent out, including whoever just sent it. So back over to scripts, we're going to listen for this event. Let's do this below our new client there. We'll do socket.on, listen for this event. We'll call what we got back, new message. And this is native JavaScript, so we'll just keep it simple. We'll go and grab this thing, the thing with the ID of messages. So document.get element by ID, messages dot inner HTML plus equals, make a new li tag, put in there our new message, and then close off the li tag. You absolutely would never use inner HTML in a real application because that is not safe, but it will be just fine for our application. So let's refresh, make sure that we don't have any errors. And we do have an error. I haven't done enough native JavaScript lately. It's complaining that our scripts are at the very top and the DOM is not finished loading. Rather than add a listener for that, let's just cut our script tags and move them all the way to the bottom of the body here. That will solve that error. Let's refresh again. Okay, no issues. Over here, let's refresh. So we've got two clients. I will send a message here. Hello, everyone. Okay, we get hello, everyone there, and we get it over here. Put in this box, I love Socket.io. Enter, it pops up here, and it pops up over here. If we add our third client, and we're not keeping track of history, so that's something you could do, like store these messages in an array and populate it. But we add our third client, chat apps are cool. It pops up there, pops up over here, pops up over here. All we are doing is inside of scripts, we are emitting this event with the text we pulled out of the DOM to the server. The server is listening for those events. As soon as it gets one from any socket, it turns around and sends this out along with the message. Everyone who's connected, including whoever just sent the message, has a listener and is going to update the DOM with that new message. That's all that is going on here. There's nothing fancy. It just takes some getting used to because it's such a different model. Go back and watch the whiteboarding section if you need to, but unlike HTTP, which is stateless and you make a connection and you disconnect, TCP is not like that. It's going to be even more asynchronous, which is even more confusing because humans just don't think like that. Either side can run those callbacks anytime because both sides can emit and those listeners will respond as soon as it happens. Just take some practice, but it is absolutely worth it in the long run. I want to spend a little time to walk you through a bigger project so you can see how it works at a little bit bigger scale. I will link the code to this project in the description. It'll be on GitHub. It is a little Agar.io clone. So Agar.io, you can go there if you want to see a better graphics, I guess, than I have. But the way that it works, I just skipped over the instructions there. But you're a little orb floating through space, and you can see up in the top right, the leaders. There's only one player right now. I'm going to send Rob all the way to the left side of the screen so that I can find him. Let me drag this out of the way and get another client up. I've got my second client up here, Rob2, play solo. You can't see the leaderboard for this one because I had to drag it out of the way a little bit, but I'm going to get enough orbs and I will go find Rob1. Okay, I found him. The board is very large, and I've made myself bigger, and I don't know if you can tell, but as you absorb orbs, you get bigger. I am about to absorb poor Rob, and notice down at the bottom here, Rob was absorbed by Rob2. If I come over to the other browser, I no longer have control, but I still can see Rob2 floating around. If I drag this down, Rob has disappeared from the leaderboard, and Rob2 is getting ever bigger. I'm going to close this down. Please follow the GitHub link in the description to grab this code if you want to walk through it with me or if you want to play with it. There are a lot of files here and only a couple that are relevant to us. Index.js is our entry point. This is what we run NodeMon or Node on. It pulls in the Express server and it pulls in the Socket server. I like to keep them separate in bigger applications, and you can check that out if you want to. Socket, well, we'll go to Express first. Express pulls both the IO and the app from servers. Socket main does the same thing. It pulls IO and it pulls app. So the actual server is made here in servers.js, And hopefully this is encouraging, because this is exactly what we just did. We have Express, we make an app, we serve it up statically, we listen, etc. Right? All of this is just what we did. At least for my apps. They all pretty much start this way. Ignore the instrument part. This is admin.io. I have another video on that I can link in the description as well. But we export both of those, the app and the I/O, so that we can abstract them to other files. We don't have anything in express.main because this isn't it doesn't need any express routes. Socket main is where all of the magic happens for this game. It is only 150 lines. Now, it's a little longer than that, because there are some classes where some of the logic is abstracted. So making the tiny little orbs, making each individual player config, and then player data, you can look at those, but really all the classes just contain, they're just big objects, sophisticated objects. Check collision is a little bit nasty. This is all the math to check and see if a given orb has run into another or a player. Socket main, though, again, is pretty much where everything happens. Inside of public, this is our front end, just like what we did a minute ago. There is an index.html, and go back up to the very top. We've got just some basic headers and whatnot. The canvas is where everything happens. This is where the game is drawn at. All of the other stuff are the leaderboard, modals, asking the player for their name, that kind of thing. At the very, very bottom, these are our JavaScript files. This is Bootstrap. Socket.io, naturally, we have to have. There is a UI stuff, so this abstracts out to one JavaScript file. Things like grabbing the user's name, updating the leaderboard. Canvas stuff is where the drawing part happens. It's what makes it feel magical, but it's also pretty boring math type stuff. So as a developer, hopefully you can appreciate that, but we don't need to go over that. Socket stuff are where all of the listeners and where all of the emits are at. Socket stuff right here. This is where we will spend our time. That first line hopefully looks very friendly. It is exactly what we just did, const socket io.connect, and then we give it our URL. I don't have a query string or auth or anything like that in there, but this is what we are going to look at. Starting over here in socket main, we grab the IO, we grab the app, but we don't need it. We don't use it, as you can tell. But we grab the server. So this is our socket server. We grab the math portion here, collisions for both the player and the individual orbs, and then we grab all of the classes. All those do, as I said, it makes it simpler to create various objects in a more standard way. All of this stuff happens when the server starts. It's not inside of a listener. So everything you're seeing here, when you run Node or NodeMon on index.js, everything down to here, I guess I should say down to here, is going to happen when the server starts up. The rest of the stuff, they're callbacks that are going to happen on events. So when the server starts up, we make an array to hold all of the orbs. There are 5,000 on our board. We build a settings object with some default. It's how big the world is, how closely zoomed in we are, the default number, that kind of thing. We build an array for the players. This is managed by the server, so that includes a bunch of configuration data that is only relevant to the server. We have another array that contains some of the data from players, but we don't want to send everything, one, because it wouldn't be fair, and two, it's extra data that we don't need to send. We want to keep our emits to the absolute minimum, and you will see why in just a second. And this is why, line 29, our tick-tock interval. We'll come back to that. On the server start, line 32, init game runs. We won't spend a lot of time there. All this does, it is a for loop that runs 5,000 times, makes a new orb, and pushes it onto the orb array. So we've got 5,000 of those little orbs. You can check out this class if you want to see what's in there, but it's like their location and their color, stuff like that. That happens on server start, and then we have a connect listener, and this goes all the way down. It's the entire file other than the leaderboard here. So everything else is inside of our connect handler. We call what connected a socket. We have a generic object called player, and then we listen for the init event. There are some other listeners here. There's a talk, there's a disconnect. Okay, there's no emits. So the server now is just waiting. It's waiting for people to connect. Once they connect, it will be waiting for an init, it will be waiting for a talk, and it will be waiting for disconnect. And that is it. So we can leave the server. It is happily waiting once it has started up. We come over to Socket Stuff. As soon as a browser loads up, the connection it starts immediately. This is going to connect. Then this file is going to wait for the init function to run. Everything in this file is in there. What would cause the init function to run? Well, I'm glad you asked. Over in UI Stuff, we have our Start Game button. When the user clicks on Start Game, we run init down here. This stuff just hides some of the stuff on the screen, but we run init, which will populate, getting ahead of myself. It's going to run the init function. What's in the init function? Well, we immediately have an await, so we are going to get blocked by this line. Emit with acknowledgement. We talked a little bit about this. Instead of just emitting, we're going to emit the init event. That was what we were waiting for back up at the top here. This is the first thing we've got. But the client is going to expect some kind of response, and the response is going to get stored inside of init data. Let's go find out what it is. We're sending over one piece of data. It's an object with the player name. All right, so someone has clicked on Start Game. So this runs. We call what we got the player object, and we scroll down a little bit. If there is nobody in the player's array, meaning this is the first player that has joined the game, we start a very important interval running. We run set interval every 33 milliseconds, which is 30 times per second. So there are 30 frames per second. That's how games work on 30 frames per second or 60 or whatever. Every 33 milliseconds, this interval is going to run, this callback here. We're going to do an io.to game, and then we emit the tick event, and we pass out this array. What's going on here? Well, io.to, on the server API, down at the very bottom under socket, there is a socket.join right here. This will add the socket to the given room or to the list of rooms. So socket.join, and then you hand it a string. Just make sure this is clear up front. Rooms are a server thing. They are not a client thing. The client has no idea what rooms they are in. They only know they have joined a given namespace. That is all they can control. If we go back up to server here and choose server.to down at the bottom, server.to, and then we give it the room, this will set a modifier for subsequent event emission that the event will only be broadcast to clients that have joined the given room. They got a couple examples here. We mentioned this before, but we don't want this event to go, again, every 33 milliseconds. We don't want to be harassing players that have joined the server but are not in the game. So that is when the room comes in really important. We've got to broadcast this event, the tick event, right? Subsequent event emissions. So emit the tick event to who? Well, to the whole server, but not the whole server, only those who are in this particular room, which right now is none because we haven't seen a join yet. We're going to send out the players for users. This is the players array, and the players array contains everybody's location and their color and their size and the leaderboard info, that kind of stuff. So this is going to go out every 33 milliseconds. We keep going down because we're still inside of our init callback here. This only happens the very first when the very first player joins. And then we run socket.join. So whoever just joined, they are the first person, this stuff happens, and then they immediately join the game room. So they are going to start getting this, again, every 33 milliseconds. We do some basic data setup here. So grab the player name from the init event, set up a player config and a player data. Those are from the classes that we've got. And then make a generic player object. That was back up here. We have a player object. We're going to overwrite it with a new player. Player class is just a config and a data together. Push that player onto the players array, and then push just the player data. So don't include the config data. Push that onto what we send out to all the players every 33 milliseconds. That's what goes out, our tick event. Then the acknowledgement callback runs. So we are done and we're ready to send back to the client who is waiting right here. There's the await, emit with acknowledgement. we're going to send back, what are we going to send back? An object that has orbs and this particular player's location in the player's array. This makes it so that they can know where to draw themselves. If they were to change it, it's not really cheating. They'll be drawing themselves in the wrong place, and the game wouldn't be any fun. But we're going to send this object back, come over to Socket Stuff. That is what's going to get stored in init data, this object. It has the orbs and where this particular player is at. The set interval starts on this side now. So this side has already started ticking, because when this person joined, the tick event has started happening. But as soon as the await comes through, we're also going to start emitting the talk event. So this is happening from both sides. It can be a little bit confusing. The server is going to let the entire player base know where everybody else is at, how big they are, and so on. Meanwhile, this particular player, or rather every individual player, is going to send up the talk event every 33 milliseconds, and it is going to let the server know this is where I have moved to. The one thing the player does control is where they're at. So it uses the mouse, where the mouse is at relative to the player. That gets sent up every 33 milliseconds so that the server can update it via talk. Okay? We're going to hold off on this stuff. Well, I guess we'll talk about it real quick. The orbs array gets set up with whatever was sent back from acknowledgement, and then we establish where the player is at in the player's array. And then the draw function gets called. The draw function takes all of the stuff from the player's array and draws everybody. Let's look at the tick event, which is right here, and let's look at the talk event, which is happening over here. So this is the server listening for each individual socket to tell them where they're at. This is the server sending out everybody's data. On tick, okay? 30 times a second, this is going to happen. You get the players array from the server. We overwrite the local players array with what we just got back from the server, and we check to see where the server says this player is at, and then we make sure that we update it locally. So the player determines up here where they want to go, but they actually get updated locally inside of the tick event. So the server is letting everybody know. So just like our message, you tell me where you want to go, and then I will tell you right here where you actually are. You could have done that yourself, but the logic is a lot easier if we just treat all the sockets or all the players the same way. That's all that tick has to do, is just overwrite the player's array locally and put this player in the right spot. Over in socket main, the talk event. A talk has come in, which means the player is sending up their data. We just have a little fail-safe here to make sure we don't start getting talks before the player has any data. This decides where that player is at. So let's go back real quick. We talk every 33 milliseconds the location that we are at. So we grab that data, we update the player's speed, we grab their location, and then we determine a couple things. Can they move, right? Are they up against the left wall or the right wall? If they are, they're stuck. If they aren't, then we can move them in that direction. Same way here. Are they up against the top or the bottom, the floor or the ceiling? If they are, then they're stuck. If they are not, then they can move in that direction. Then we run some checks to see, have they run into any orbs? And if they have, get rid of that orb, create a new orb, and then let the whole game know, right? So io.to game emit. So emit the orb switch event to everybody on the server who's in the game room and send out the new orb data, because we want 5,000 orbs all the time. Otherwise, you'd eventually run out of orbs and nobody could get bigger. This will make sure that every time an orb is eaten, a new one will get sent out to the whole server. And likewise, we're going to update the leaderboard because someone just ate an orb. So update the leaderboard, and then this function's down at the bottom. We keep going. Now we check to see, has a player collided with the talking player? Check for collisions. If that has happened, remember that pink message that said Rob was absorbed by Rob 2? We're going to send out an event to the whole game room that someone was absorbed with the data that we get back from this function. You can look at it. And we also tell the leaderboard to update, because that makes a big difference when you absorb another player. That is the talk event, and that is pretty much it. We have the disconnect event. This happens because someone closes the browser or they refresh or something like that. We need to remove them from the players array so they're not drawn anymore. We also want to stop ticking to them, because otherwise the server will keep sending stuff out. We don't need to do that anymore if there's nobody left, because if the game is over, that function doesn't need to run anymore. That's everything that happens inside the server. Back over to the browser, we had the tick event we already talked about. This is the orb switch one. I mentioned that when an orb gets absorbed, we need to update the orbs array. I mentioned the player absorbed. Someone got eaten. You saw that, as I mentioned. Rob was absorbed by Rob2. This happened back up here, right here. And then the update leaderboard, that happens in the same part here, if a player gets absorbed or a regular orb gets absorbed. That is pretty much everything that's happening in this game. Now, yes, there's a lot of canvas logic, and yes, there's a whole bunch of UI logic that you can look through, but it really comes down to someone joins the server, io.onConnect. We start listing for 3 different things: init, talk, and disconnect. And that's it. We also, as soon as one player has joined, we start sending out every 33 milliseconds the tick event. On the client, it's everything pretty much in reverse. As soon as a player clicks on start game, this function runs. We send over the init event, hey, I'm ready to start playing the game, and then we start talking. The server listens for the talk and updates accordingly. Down here, the player starts listening for tick, which so it can decide where to draw the players. That is an awesome example, I think, of Socket.io. And games are fun to play too. But check out the code base. Go a little bit farther if you would like to. I tried to keep it very simple. I make this project in a Udemy course. If you want to check that out, I'll drop a link I can give in the description if you want to. But hopefully you've got everything you need here to start using Socket.io. I said this way back at the beginning, but it is such an incredible API. Doing stuff with Socket.io, bidirectional, low latency, TCP, keeping connections open, is something that you absolutely can and should be using. It's just not okay anymore to have apps that are not real time. Whatever it happens to be, we need to be using this more and more. You can use WebSockets, but Socket.io is a souped up version of WebSockets, which comes with a whole bunch of extra features that, again, you absolutely will get good use out of. I hope this has been helpful. You can look for other videos as I will continue to build on this, and we'll go over other methods. We'll talk about namespaces in other videos and so on. Thanks so much for watching. Go write some Socket.io.